Okay, then next, to determine the coefficients of permeability for fine soil, so the laboratory test that need to be conducted is the falling head test. This is the falling head test for fine soil, which is clay or silt. Alright, so this is for the falling head test. The schematic diagrams, the arrangements of the falling head test. The difference is that for the standpipe that we will use in falling head test is more than one, then it will have the different diameters of the standpipes. So you will have the area of the standpipe, and also you will have the area of the sample here. Alright, so how the procedure of the test is by filling the standpipe with the water and allowing seepage to take place through the sample. Alright, so you will allow the water is actually from here, and then it will move going up and down to fill up the soil sample. We will allow the soil to penetrate, because this is the fine soil, so the void is very minimum, so it will take a longer time than constant heat test. Alright, and then we need to set the initial H, right? So we need to set the initial H. For example, we want to set it start from 1000 ml, and then we already planned that for the final H is at 700 ml. So we set this one first, because we need to record the duration of the flowing of water from 1000 ml to 700 ml. Alright, so when the flowing of water in the standpipes is constant, ready to start the experiment, and then at 1000 ml you record the start time. We start the timer, and then slowly wait until the soil reduced to 700 ml as we said earlier. Okay, so when it reached 700 ml, so we stop the timer, and then we record the time taken or the durations of water from 1000 ml to 700 ml. Alright, so then you repeat the experiment for the next standpipe. Okay, repeat the experiment for the next standpipe that have another different diameter, and then once complete, repeat with another standpipe. Alright, so this is how the derivations of the equation for the falling head test. Again, so we have the Darcy's law here, so V equal to Ki, and again you have the Q equivalent to VA. Alright, so now the V we can substitute with this one. Alright, so we have this X equation. Now since we have the area of standpipe, so we need to consider that the movement of water, the flowing of water is in the standpipe. So we will have that this one Q will equivalent to negative A dH over dt. Alright, so this is for the area of standpipe. The negative sign refer to the falling conditions, because the water was falling from the 1000 here, dropped to 700 ml. Okay, now so we have the dH dt, the head fall, okay, level of water falling in HDH in unit time. Alright, so we measured the head loss in unit time. So now since we have these two Q, so we will have the one equilibrium equation here. So we can substitute the I, the hydraulic gradient, with H over L. So we have this one, and this is the arrangement, and we rearrange and integrate. So this is the maths equation. The rest is the maths actually. So don't forget the negative sign. Okay, we will carry the negative sign till the end of the equation. So all the DH, so we have the H here, so kita bawa dia ke sini for DH over H, and the rest is on the right side. And then bila kita integrate, so you will have the ln H here, don't forget the negative sign. So here T, you will have T2 minus T1. Alright, and then this is ln, negative ln H2 minus ln H1. So considering the negative sign, so you will have negative ln H2 plus ln H1. So the ln H1 is more than H2, so the H1 is at the top part, at the above. So here is ln H1 over ln H2, so here is Ka over Al, T2 minus T1. T2 minus T1 is the duration. So at the end of the day, so this is the final equation. Again, the unit of the K is distance over with time. Alright, so it can be mm per second, meter per hour. Okay, so don't forget that what is H1 and H2 just now is the initial and final heat. Small letter A is for the area of standpipe, L is for the length of the sample, and T2 minus T1 is the duration. So this is an example. Okay, this is an example. If you look at the example, you have the information here. Initial heat is H1, final heat is H2. Here is already given the duration, means that 2 minutes here is T2 minus T1. So you don't need to find out where is the T2, where is the T1. Okay, so if it mentioned yes, you have T1, T2, yes, you need to calculate T2 minus T1. But then if it's already mentioned about the duration, so it refers to T2 minus T1 straight away. And then also have the sample diameter. So from the sample diameter, you can get the area of the sample. And from the standpipe diameter, you will have the area of standpipe with the sample length is 150 mm. So look at here that they want you to calculate the K but in the unit of mm per second. So make sure that minute here, the duration convert into second. And then, straight away, using this equation, alright, you complete the calculation. So you will have, this is the K value. Since this is the fine soil, so the K value normally very small value, very low. Normally it will have the exponent here, exponent negative something, because this is the fine soil. The K value will be smaller than the coarse soil. Okay.